Okay, so we are in your yellow book on page 55 this year. And again, we're going to be talking about balancing equations or balancing reactions. And we're going to be using the counting of atoms that we just talked about earlier. Now, we may or may not have gone into chemical reactions yet, but when you see a chemical reaction, there's two sides to it. There is the left side and there is the right side. And on the left side, these are called the reactants. And on the right side, it's called the products. And this symbol here says yields. That's what that stands for. So when we go to do a chemical reaction, these are the two things that we're going to actually take and put together. So you kind of think of those as those being our independent here, because this is what we're actually going to be using. We're going to be putting that into the test tubes or whatever the case may be. This is going to yield, or this is what it's going to make for the reaction. Now, we're going to be talking about all different kinds of reactions and so forth, but I just want to introduce to you balancing of chemical reactions. And what we mean by balancing of chemical reactions is when we get the number of atoms to equal on both sides. So we have to have the same number of atoms on each side. Now, we're talking about for each of the different elements that we have. So let me just do a couple of these, and then you can do your own. So the first thing that I would do is I come in here to the middle, kind of just in the middle here, and I write down each of my elements that I have. So in this case, I have 10, I have oxygen, and I have hydrogen. Okay, that's what I have to start with. I just write them down. Now I'm going to do the counting that we did earlier. So when I look at this, I have 110, I have 2 oxygens, and I have 2 hydrogens. Okay, so that is on my reactant side. On my product side, I have the 110, I have 2 hydrogens, and 1 oxygen. So when I look at this, I see that they are not the same on both sides for all of them. And that's what our goal is. We want 10 to be exactly the same, which it is right now, so that's great. Oxygen to be the same, which it's not. And hydrogen to be the same, which it is not. And so I need to do something. And in order to do something, we're going to add, again, coefficients. We talked about that on the counting. We're going to add coefficients. So what that means is we're going to actually put numbers in front to get it to balance. So let me just again run you through it. So on this side, I have 2 oxygens, so I'm going to have 2 on this side. And the way we do it is we put a coefficient. Now, guys, when you're looking at your balanced or your chemical equation, you're not ever going to change your subscripts. That we did when we balanced our compound. We're balancing the reaction, 2 different things. So when I put this 2 here, I have to recount. Okay? So I now have 4 hydrogens. Okay? And I have to have 2 oxygens. Okay? So I was able to get my 10 the same number. Now my oxygens are same number, but I messed up my hydrogens. So I have 4 on this side now, but I only have 2 on this side. So I'm going to come back over here and I'm going to look, and I need 2 more hydrogens. So in other words, I need 4 of them. So remember, this is like a distributive property. So if I put a 2 here, 2 times 2 now makes me have 4. And since hydrogen is by itself, I didn't change any one of these. Okay? Now let's go back in and always go back and recount. I have 110. I have 2 oxygens, and 2 times 2, I have 4 hydrogens. On this side, I have 110. 2 times 2 is 4 hydrogens, and then 2 times that 1 is 2 oxygens. And so this is now balanced, is what we call it. Now, one of the things that you can do, you do not have to do, is put the 1s out in front if that makes you feel good. So it's not required to put a 1. It's just like if you say X, you don't have to put a 1X out in front of it. It's not wrong, but you don't have to have it. Now, what I do want to say is that if you are doing this in just a little bit, or maybe on a quiz or whatever the case may be, one of the ways in which I write the answer to a balanced equation, just so I don't have to keep rewriting this, but in order to make it a multiple choice, is I just write the coefficients. So for this one, it would be 1, 2, 1, 2. And that's telling me 1, 2, 1, 2. In that case, you would want to put the ones there again as a placeholder. Okay? So let's try another one. I have hydrogen. I have nitrogen. Let's count it up. So let's go to our reactant side. I have 2 hydrogens. I have 2 nitrogens. On the other side, I have 3 hydrogens. Make sure I'm getting the right one. And I have 1 nitrogen. Okay? So in this case, neither one of them are balanced. Okay? I don't have the same number for either one of them. And so I'm just going to have to kind of start in. So I know I need 2 nitrogens here. I only have 1 on this side. So I need a 2 for sure here. Now, it's possible that the first number I choose is not going to work. So I may have to back up and do something else. But let's recount. 2 times nitrogen, there's a 1 here. So 2 times 1, 2 times 3, make sure I got that right, 2 nitrogens, 6 hydrogens. So that fixed my nitrogens. So now I need to fix my hydrogens. I need 6, I only have 2. But every time I get a hydrogen, I get 2 every time. Okay, so I need 3 of those pairs to get 6. Okay. Next one. I have selenium, I have chlorine, I have oxygen. Take a minute and count. Make sure you get the same count that I do. So I have 1 selenium, 6 chlorines. My eyes are tired. I can't tell if that's a 6 or a 5. I think it's a 6. Okay. And I have 2 oxygens. So there's my count. Did you get that? On this side, I have 1 selenium, 2 oxygens, and 2 chlorines. Again, I need to make them the same. So what is not matching up is definitely the chlorines right here. I had 6 on this side. I only have 2 on this side. Again, they come in pairs of 2. So if I have 3 pair of 2, 3 times 2, I'm going to get 6. Okay, and it looks like everything is good. I'm going to back up just for a second. I'm going to put a 1 there and just remind you that's would be written 3, 1, 2. This one, all I needed was a 3 there. So these are all 1s. 1, 1, 1, 3. Okay. Aluminum, oxygen. I have 1 aluminum. I have 2 oxygens. I have 2 aluminums and 3 oxygens. Okay, I need to get them the same. Okay, so we can kind of start wherever we want. I generally prefer, if I'm given the choice of aluminum or oxygen, oxygen has to come in pairs. So I tend to want to start with it versus just a 1, because I can put any number in here. But when I put numbers in here, it's going to make even numbers. Hopefully that makes sense. So I need my oxygen. It's kind of like when we were balancing our compounds. I have 3 here and 2 here. I need them the same. So if I put a 2 here, that's going to give me 6 oxygens. So if I'm looking at just my oxygen, there's 6. So I need 3 here. That's going to give me 6 also. 3 times 2, 2 times 3. Now remember though, on this side, I also have aluminum. So by putting that 2 there, I also changed my aluminum. 2 times 2, I have 4 aluminums. Therefore, I need to come over here and fix my aluminum. There's only 1 here, so I just need 4. 4 times 1 is 4. So this answer would be a 4, 3, 2. Okay, let's see if we can get through a couple more. Sodium, chlorine, oxygen. Sodium. Now, be careful. Whoops, I put nitrogen. Sodium. I have 1 chlorine, 3 oxygens. On this side, I have the 1 sodium, 1 chlorine, and 2 oxygens. So this one's very similar to the last one I did. I've got the 2 and the 3. These come in groups of 3. These come in groups of 2. I need the same number. So if I have 2 of these, that's going to give me 6. And if I have 3 of these, that will give me 6. Okay. Now the only problem is that when I put that 2 there, I changed everybody. So I now have 2 sodiums and 2 chlorines, which in luck, sodium and chloride are both together over here. So by putting a 2 there, I now have 2 sodiums and 2 chlorines. Fun, fun. Okay. I think I can do one more and stay within my 15-minute time frame. Never can be over 15 because that's all I can upload to YouTube. Aluminum is a 1. Bromine is a 3. Chlorine is a 2. Aluminum is a 1. Chlorine is a 3. Bromine is a 2. So it looks like both my bromine and my chlorine are messed up. So you can kind of start wherever. But since bromine is here, I'm probably going to go ahead and start with it. My chlorine is by itself here. So 2 and 3, same issue we've had before. I need to get these to be the same. 6 is where it's going to go. So if I have 2 of those, that's going to make 2 aluminum and 6 bromine, okay, which is what I was going for, the 6 bromine. I'm going to come over here and I want my 6 bromine. So I'm going to put a 3 there, and there's my 6 bromine. Okay. Now I need to fix my aluminum on this side. So I have 1 on this side, or sorry, 2 on this side, 1 on this one. So I'm going to put a 2 to double the aluminums. That's also going to affect my chlorines. So 2 times 3 is 6 chlorines. I'm getting closer. Okay. So chlorine on this side is the only thing that's messed up now. I need it to be 6. I have pairs of them. So I need 3 pairs of 2 to give me 6. And again, I definitely always go back in and double check. I haven't on all of them, but do. So there's 2 aluminums, 6 bromines, 6 bromines, 6 chlorines, 6 chlorines. And I'm balanced. Again, if I write this out, it would be a 2, 3, 2, 3. I skipped this one up here. It would be a 2, 2, and a 3. Okay. So you're going to try the ones at the bottom. So this is on the YouTube, page 55. You're going to try those at the bottom and see if you can get them done. Now, guys, when you're doing this, if you don't have room to write all this out, you can put it on another sheet of paper. Some of you, I know, are very number-oriented, mathematically oriented. You can see. I'm okay with you not writing that if that is the case. But I strongly suggest for starting out, you write that out. That's just my suggestion.